and welcome back to your second round of video notes. We're going to go ahead and get started, so please turn to your table of content and fill in. Today's section is going to be 1.12. We're going to be adding and subtracting like fractions. I'm going to be on page 28. However, you're going to turn to your next blank page for these sets of notes, so please keep that up to date. I'm going to go ahead and turn to page 28 now. Make sure you put the section, the title of today's section, and the date. The glue-in for this page is the one with the diagrams on page 29. The one with example 4, 5, and 6 are on this page. Make sure you put the section, continued, and today's date. So go ahead and pause the video right now so you can glue that in. Okay, so I'm going to go ahead and get started. Today we're going to be talking about fractions with like denominators. So fractions with like denominators is the same thing as saying fractions, like fractions. Okay, so let's say we have 5 over 7. The denominator in 5 over 7, or 5/7, is the 7, so the number on the bottom. The number on the top are called numerators. Okay, so that's the number on the top, the 5. Okay. Let's go ahead and look at this first diagram that we have here. We have 1/5 here, and we have 5 bars, but we only have 5 out of those 5. We only have 1 out of those 5, so I'm going to go ahead and shade only one of those bars. Okay, I want to add this 1/5 to this 3/5. So out of these 5 bars, I'm only going to shade in 3. Okay, so here I have 1, here I have 3. Okay, so how many do I have in total? I have 1, 2, 3, 4 bars. Okay, I only have 4 out of those 5 bars. Okay, so if you notice, all we added were the numerators. We just took the numerators, we added them, and it gave us 4 out of 5, so 4/5. Okay, so whenever the denominator is the same, so notice that the denominator was the same. All we're going to do, we're going to keep the denominator the same. If the denominator is the same, we keep it the same. So the denominator stays the same. Okay. You're not required to draw this out for your homework or for your quiz. It was just for our understanding of what it means to add fractions. Okay, so we're going to go ahead and look at our 3 examples on the bottom. We have 7/13 plus 4/13. Okay, the denominator is the same, so that means the denominator stays the same. I just need to add the numerator, so I just need to add 7 plus 4, which gives me 11 over 13. And so these don't have anything in common, and so that's going to be my final answer, 11/13. Okay. Example number 2. Again, we have 9 as our denominator for both of the fractions. So the denominator is going to stay the same. It's going to stay 9. And we just add our numerator, which is 5 over 2, which gives me 7 over 9. These, again, don't have anything in common. So that's my final answer. We're going to look at example number 3. We have a negative there. Okay, so we're going to have to use one of the rules that we have learned. The denominator is the same, so that stays as a 5. We have 1 plus negative 4. There are different signs here, so I'm going to use DSD. And when I use DSD, that means I need to subtract. Okay, so that means I need to subtract 4 minus 1. 4 minus 1 gives me 3. However, we need to look back and look at which absolute value is greater. In this case, the 4 has a bigger absolute value, and the 4 is negative, so then our answer is going to be negative 3 fifths. And this would be our final answer. Just a quick FYI. Okay, we could have negative 3 fifths, or we could have negative 3 fifths, or we could have 3 over negative 5 3 fifths. Okay, these three fractions are all equivalent. They all equal the same thing. Okay, they're all telling you the same thing. Okay, so you might encounter one of these. Just note, it's just a negative fraction. I'm going to go ahead and turn on to page 29 and look at example number 3. In this one, it's subtraction, and when we have subtraction, we do the KCC. Okay. I'm going to keep the first fraction the same. I'm going to change the subtraction to addition, and I'm going to change the 9/10 to its opposite, which is negative 9/10. Now I can go ahead and add these out. So we have same denominator, numerators. I'm going to go ahead and add those. They're different signs, so I'm going to do DSD. When I do DSD, I subtract. And so I need to do 9 minus 3, which is 6. However, the absolute value for 9 is greater than the absolute value of 3, so that means my answer is going to be negative 6 over 10. However, these two numbers have something in common. So we need to simplify. So I'm going to do this in a different color, the simplifying process. So we need to simplify negative 6 over 10. So negative 6/10. We need to simplify this section. So I'm going to look into factors of 6 and factors of 10. So I need two numbers that when we multiply them, they give me 6. I know that 1 times 6 gives me 6. And I know that 2 times 3 give me 6. Let's look at number 10. Factors of 10. I know that 1 times 10 give me 10. And I know that 2 times 5 give me 10. So looking at these two factors, which one do they have in common? Well, I can see that the number 2 goes into 6 and number 2 goes into 10. So number 2 is a factor of both of these. So that means that what I'm going to do, I'm going to take negative 6 over 10. So 6/10, negative 6/10. I'm going to divide by 2. My numerator and my denominator, I'm going to divide that. So 6 divided by 2 is 3, and the 6 is negative, so it's going to be a negative 3. And then we have 10 divided by 2, which is 5. And so our final answer would be negative 3 fifths. Okay. Looking at example number 5. Denominators are alike. They're the same, so it's going to stay as a 5. And then I just add 4 plus 3. 4 plus 3 is 7, and so our answer is 7 over 5, so 7 fifths. However, this here is an improper fraction. And when we're doing fractions, we don't want improper fractions as an answer. So we need to change this to a mixed number. So down here, what we're going to do, we're going to do the steps to changing an improper fraction into a mixed number. So we take the fraction 7 over 5. Okay, I know that 5 will go into 7 once. Okay, so I know that 5 goes into 7 once. So we do 5 over 5. Okay, what we have as a remainder would be 2 over 5. Okay, so 5 5 plus 2 gives us 7. So these two numbers should add up to your numerator whenever you're splitting it up. And then we have 5 divided by 5 is the same thing as 1. And add the 2/5. And so our mixed number would be 1 and 2/5 for our final answer. So that would be our final answer, 1 and 2/5. Example number 6, we have -3/8 plus 1 and 1/8. I can't add these because this one's a proper fraction and this one's a mixed fraction, a mixed number. I need to change this mixed number into an improper fraction, and then I can go ahead and add that. So what I need to do, I need to take, let's go ahead and label what we're going to do right now. We're going to do mixed number into an improper fraction. So I need to take, I'm going to go ahead, please go ahead and change this to a 2. That was one of my typos, so please change that to a 2. So what we're going to do is we're going to take 2 and 1/8. We're going to go ahead and convert that. So I need to take 8 times 2. So I'm taking my numerator times the whole number, and then I'm going to add 1. So again, I'm taking the denominator, I'm multiplying it by the whole number, and then I'm adding the numerator. And that should give me, so this is 16 plus 1, 17. 17 over 8 would be my improper fraction for 2 and 1/8. Okay, so now I can go ahead and add it. So I'm going to rewrite the problem. -3/8 plus 17/8. Denominator are the same, so I'm going to keep it as an 8, and I can do -3 plus 17 on my numerator. They are different signs, so I'm going to do DSD for this one, and we're going to subtract. Whenever they're DSD, we subtract. Okay, so I'm going to do 17 times 3 gives me 14. And then I have to check back which one has a bigger absolute value. The 17 does, and the 17 is positive, so my answer should be positive. And so that's 14 over 8. Okay. Again, this is an improper fraction, and we want it to be a mixed number for our final answer. So I need to convert that into a mixed number. 8 goes into 14 once, so it's going to be 8 over 8 for the first one. And what I have remaining would be 6 over 8. So 8 plus 6 gives me 14. Okay. And so I have 8 divided by 8 is 1 and 6/8. Okay, this is not our final answer because the 6 and the 8 have something in common. And the number they have in common is 2. So if you go ahead, I'm going to do this over here to simplify it. We have 6 and we have 8. Two numbers that multiply to give you 6 is 1 times 6, and 2 times 3 also give you 6. For 8, 1 times 8 give you 8, and then 2 times 4 give you 8. We look at this, and what they have in common is the 2 again, just like the previous problem. That's a coincidence. It's not always a 2. So we're going to go ahead and divide by 2, our numerator and our denominator. And so for our final answer, we should get 1. 6 divided by 2 is 3, and 4 divided by 2 is 4. And so our final answer is 1 and 3.